Okay, class, 1.6, we're going to classify polygons. This is fairly short, fairly straightforward, but you have to remember a lot of the vocab, so we're going to go through it. So we're going to identify a polygon. In geometry, a figure that lies in a plane, so on the floor, on a wall, is called a plane figure. A polygon is a closed plane figure with the following properties, so it's closed. It is formed by 3 or more line segments called sides. So it has to have 3 or more sides. Each side intersects exactly 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. Each endpoint, so here's of a side, is a vertex of the polygon, so you can see all these vertexes. The plural of vertex is vertices. So if we say vertices, it has obviously more than one. A polygon can be named by listing the vertices in consecutive order. For example, so it's going to go alphabetically. A, B, C, D, E, and C, D, E, A, B are both correct names for the polygon at the right, as long as you're doing it in alphabetical order. But more than seeing this, you would most probably see it like this. It makes it so much simpler. Okay, so now we've gone through the examples. Let's have a look here. So a polygon is convex if no line that contains a side of the polygon contains a point in the interior, so the inside of the polygon. A polygon that is not convex is called non-convex or concave. So you'll see convex and concave. So here is a convex polygon, all right? So closed figure, everything is on the outside here. Here's an example of a polygon. It's a closed figure, but look, you've got a line going through here, so that's what we would call a concave polygon. So you can see the difference. So you want to draw and make sure that you have these two examples for convex and concave. Remember what I said. If I'm allowing you to use notes at times, this has to be in your notes, or you won't have anything to look at. So make sure you take good notes. Okay, we are going to identify, tell whether the figure is a polygon, whether it's convex or concave. So the first thing they want is whether it's polygon, and then convex or concave. So there's 2 parts of it. So part A, look at this. Some segments intersect more than 2 segments. So right here you can see this line in here. So that means it's not a polygon. So it breaks the first rule. So it doesn't matter about convex or concave because it's not a polygon. Then B, we can clearly see that's a closed figure with nothing intersecting, so it is a polygon, and there's nothing concave about it. It looks exactly like this, so this is a convex polygon. Then the third one here, closed figure, but you have this part going like this, so part of the figure is not a segment. So remember, your segments are straight lines, so anytime you see this, that means it's not going to be a polygon. All right, here you can see that this is a polygon for sure, but it's a concave, okay? It doesn't look like this. This is convex, this is a concave polygon, so you can clearly see the difference between them. So that's what you're going to be practicing on homework, labeling things so you can tell whether they're polygons, not polygons, they're convex or concave. So here's a list. Some of them you know, the others you want to write down. So a polygon is named by the number of its sides. So if it has 3 sides, it's a triangle. All familiar with that. 4 sides is a quadrilateral. Again, we're familiar. A lot of people know that a 5-sided shape is a pentagon. 6 is a hexagon. 7, sometimes people are not so sure, that's called a heptagon. 8 is an octagon. 9 is a nonagon. 10 is a decagon. 12 is a dodecagon. and n means n-gon. Whether you can have a side with 15, so you'd call it a 15-gon, okay, or a 16-gon. But certain ones like these we know. So if someone tells you a hexagon, you should know, okay, 6-sided, or an octagon's 8-sided. So the term n-gon, where n is the number of polygon sides, can also be used to name a polygon. Just like I said, for example, polygon with 14 sides is called 14-gon. In an equilateral polygon, all sides are congruent. In an equiangular polygon, all angles in the interior of the polygon are congruent. So equilateral means these markings means all these sides are the same. And then by the angles right here, these markings mean all the angles are the same. So a regular polygon, and this is really important that you have this definition because they're going to ask you if something's a regular polygon, is a convex polygon. You can see that's convex, not concave. That is both equilateral, all the sides are the same, and equiangular. So this is an example of a regular pentagon. So that's what tells you if it's regular or not. So let's go ahead and classify. So this is a fairly easy section, 1.6. So classify the polygon by the number of sides. So that's the first thing. Tell whether the polygon is equilateral, equiangular, or regular. Explain your reasoning. So first off, that's got 1, 2, 3, 4, 5. It's a 6-sided shape. So a 6-sided shape is a hexagon. All right. Also, all the sides are the same and all the angles are the same. So this is a regular hexagon. So it's real easy to see. Now we're going to look here. So this has got 4 sides. So we know it's a quadrilateral because it has 4 sides. It is not equilateral. These angles are the same, but these angles are the same, but all 4 of them are not the same. Same with the sides. The sides are not the same. So this is not a regular polygon. All right, last one here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like it's a 12-sided shape. So I'm looking here, and all the sides are the same. So we would call that a dodecan. So 12-sided shape is a dodecan. The sides are congruent, and I can see all the angles are congruent. The polygon is not convex, so it's not regular. So see how we're going through different examples. So the only one that was regular that met everything, where all the sides were the same, all the angles were the same, and they were all convex, was A. B was not a regular polygon, nor was C. Even C had the same sides, the same angles. It was not convex, it's concave. So be careful that you understand the definition. If you do, then it's going to be easy. All right, last thing here, and we're going to work this out together. We're just going to read this and then work out how we would do this. Okay. A table is shaped like a regular hexagon. That's the key. Regular means that all these sides are the same, and there's 6 of them. The expression shown represents side lengths of the hexagonal table. Find the lengths of a side. So I know that this is 4x minus 2, this is 3x plus 6. So again, we've got variables, so you need to be thinking algebra. So how do I take that and find what the length of a side is? Because all the sides are going to be the same. It doesn't tell us anything else. So hopefully you're looking and you realize that these are equal to each other. So that's exactly what we're going to use. So we're going to take, and we're going to go ahead and use that. That this one side, 3x plus 6, is equal to the other length, which is 4x minus 2. That's the only way. is find what x is, then plug it in, and we should plug it into both of them. They should both be the same, then we know we're right. So remember, you can choose to do it the easy way or hard way. If I subtract 4x, I end up with a negative x. If I subtract 3x from this side, I end up with a positive x. So I always go with what's the easiest. Okay, so I'm left with 6 equals 4x minus 3x is x, and then bring down the minus 2. Add 2. So x is 6 plus 2 is 8. Sorry, now we have to make it a little bigger to, okay, we can fill the space better. So now I'm going to go back and I say 3 times 8 plus 6, that's one side, and the other one's going to be 4 times 8 minus 2. We should get the same thing. 3 times 8 is 24. 24 plus 6 is 32. 4 times 8 is 32 minus, let me see, 4 times, yeah, 8 is 32 minus 2 is 30. Must have done something wrong here. 3 times 8 is 24, sorry, plus 6, not 8. I was thinking 8 from here is 30. I knew something was wrong, so I double check. Okay, they both are 30, so I know it's correct then. So that's how you would find the lengths of a side. So remember, as you're reading stuff, underline. The regular is really important. That tells you all the lengths are the same, so you can set them equal. So that's what you're going to be doing a lot of. And we are done with 1.6. It was fairly short and easy.